So, good afternoon, everybody. I will start today chapter 10 related to age and sex composition. And I saw that the majority of students who are enrolled to the class took quiz one in much higher proportion than previous semester. So that's good because those points in quizzes are 20% of your final grade. So yeah, just keep doing it. And most of the people got at least one correct and two correct. So that's a good thing. I will just start here with just this slide from the previous class that I showed you, and some of you wisely asked why these numbers here alive in 2019 were actually larger for these newer generations than the number born in total. And I just checked in the article, and it was not clear there. So I emailed the Poston, and he just mentioned that for these two columns here, these are the number of people born in the US. So those are US born people for this column here. And we get this column divided by the number of years in this interval, we get these numbers here. And for this column, alive in 2019, it includes immigrants. So people who came to the US, not born in the US, foreign born, and moved here in these last years, they increase these numbers. So these numbers here are higher than here exactly because we have immigrants living in the US that were born back in their home countries in between those years, okay? So that's the reason. But it was really good that you guys asked because then I make it more clear, the title of these columns here, and I uploaded it again to the course website. And in the course website, I also, under lecture of the chapter 1, I included this other link here, article about cohort definitions by Dudley Poston, which is exactly the short article. If you want to just take a look at it, he just gives some short description of what these specific generations are, the birth cohorts are, and just these 2 pages, and that table that I pretty much typed, I copied from here, from his article, right? So that's where I got the information from. Great. So this file is available PDF to download under the link of the lecture related to chapter 1. And now on the chapter about age and sex composition. So we will jump ahead on the textbook. We just discussed chapter 1, and now we are going to chapter 10. And then afterwards, after we finish this one, we also will continue more advanced chapters talking about trends and demographic variables in the world and also in the US. And then we go back into chapter 2. And just for those at home, let me just see if I can see the chat. I think I will be able to see the chat here. Yeah, you can either mute yourself and ask a question, or you can also write something in the chat if you want. So this chapter here, I'm subdividing all these topics, just give an introduction about what age and sex, these concepts in demography are, and going a little deeper. And then here in these theoretical issues is just to give you a general, really simple idea of how previous demographers trying to understand these compositions of age and sex to create some theories to explain demographic changes over time. And then we're going to talk about population pyramid. It's something that you might have seen in high school. The population pyramid just shows the number or the proportion of people by sex and age in a single graph. And because these graphs nowadays, they don't have such more like a pyramid shape, we usually call it age-sex structure, right? A graph that's showing age-sex structure. And then afterwards, I'm going to show you some other indicators that we can understand age structure of specific countries in specific years. So we have age dependency and age heaping. Age heaping is actually a problem that you might have when you collect information about age, when people usually report ages that end with specific numbers like 10, 15, 20, 25, instead of reporting their correct age. And then I'm going to talk to you a little bit, also some measures to understand sex structure in specific countries, specific years, and sex ratio at birth is a really good measure. Simple measure. It's related to the sex ratio that we saw in the previous lecture. And it, in this case, it just compares the size of boys and girls being born in a specific year, in a specific country, instead of taking the population, the whole population. We just get those people that were born in a specific year. And then all that, understanding how our population is composed in terms of age and sex, it's good because then we can understand that our population is getting older. So we have a higher proportion of people in older ages. And why is this population age important for us? Why is it important to understand it? So I'll also give you some quick examples of why understanding this topic is important for social scientists. So age and sex are the most important and relevant characteristics of populations for demographers. And pretty much you asking people what's their age and sex, you can understand what's the structure of the population in a specific year in a specific place. And they are actually known as a demographic characteristic. So when you hear someone saying or asking what's the demographics of that population, usually they're referring to what's the proportion of men and women, what's the proportion of children, what's the proportion of adult population, what's the proportion of older people. Of course, sometimes you ask the demographics, people will go further, not just talk about age and sex, but you also give you information about the composition of the population in terms of race, ethnicity, and so on. And why age and sex, this information about the structure of the population is so important for demographers? Because they are really correlated with the three components in demography: fertility, mortality, and migration. If women in a specific country start to have a lot of children, more children that they were having in previous years on average, for example, what happened after World War II, the baby boom generation was born after that, fertility increased a lot. When you increase fertility on average compared to previous years, that will create in the short term a higher proportion of children in that population. So it's going to change the age structure. And as those people from the baby boom cohort get older, they will make the working age population larger, even like in absolute terms and proportional terms, in the next decades. And then when they are in labor ages, that's when they tend to have children. So you're going to have all this large group of people that were born after World War II having children, and that will increase again the number of children being born in that country. I think my video there is frozen. I don't know what's going on. This classroom has these issues. But can you all hear me from home?
Yes.
Thank you. Thanks. I was going to type in the chat because if you're not hearing, you would not answer. So the same thing about mortality. if we have improvements in health conditions in a specific country, and then people start to live longer, you will start to see a higher proportion of people in older ages, right? Having a larger proportion of people in older ages, you're going to experience population aging, and that's changing age structure. So fertility and mortality are really related to that. But migration as well. Usually, countries that receive immigrants, they have the highest rates among the ages of 20 to 29. So these are the people that usually migrate from one country to the other if you're talking about international migration. So if you have a country receiving a lot of these people, they will have an increase in the proportion of people of like in young adult age groups. And that's going to change the age structure of that country. And it's going to affect also the age structure of the country of origin. I guess my video is back. It's kind of pausing there. So, but then again, if you have a lot of immigrants coming to a country, let's say concentrated between the ages of 20 and 29, they're also at ages of having children. So migration will affect age structure right there in the short term, but then in the long term, is going to affect the proportion of children in that country, affecting again age structure, and having more children is going to affect later on the number of people that will be able to have children again in future generations. So it's all these complex associations, right? Changes in fertility, mortality, migration are associated with changes in age and sex structure, in the sense that fertility, mortality, and migration cause these changes, but then age and sex structure also influence changes in the demographic processes. Age, sex structure also cause changes in fertility, mortality, and migration. Cool. So just to explain what exactly is age, what exactly is sex, what are these variables, what is the concept? We have to understand what's the concept in order to be able to measure it. So age is an ascribed and changeable characteristics, usually in population censuses, also called demographic censuses. It is usually defined in terms of the age of a person at his or her last birthday. The formal definition of age by the United Nations is that age is estimated or calculated interval of time between the date of birth and the date of the census, expressed in complete solar years, right? So that's how we think about age, about related to the birthday, and then comparing to the year when you are getting this information from the person. Sex is an ascribed characteristic, and for most people is unchangeable. For most people, sex is fixed at birth, but there are some who do change their sex. But usually it's fixed at birth. We know that there are exceptions, but also the information about sex has been debated a lot in these recent decades, that usually we collect information about sex self-reported, and we just give the options of male and female, but there are some surveys more recently that also include other options such as non-binary as well. But usually older surveys and censuses, and even current ones that we are collecting information, you classify yourself as being either male or female. And one important thing here for demographers is to kind of like differentiate between these terms sex and gender. Sex, for the most part, though not always, is an ascribed variable whose designation is based on biology, exactly what I just mentioned before. In gender, it is more often used when discussing non-biological differences between males and females. So for example, we talk a lot in the US about even comparing men and women of different of similar education, similar age, similar occupation, similar experience in the labor market, if they are doing the same job, usually women receive 30% less earnings than men on average. Like their earnings are 30% lower than the earnings of men. In that case, I'm talking about the labor market outcome, earnings, and the differences by sex between men and women. In that case, I'm bringing, it's not because women or men, they know better or worse how to do specific activities. It's how our society, our culture is organized. It's set up in this unfair way that women get lower earnings than men on average, even controlling for everything else, even controlling women and men, like I said before, with the same race, ethnicity, the same education, the same age, the same experience in the labor market. When we talk about that, about these differentials of a series of different indicators by sex, I'm doing more a gender study, right? I'm trying to understand why these indicators vary by sex. And these differences between males and females can be migration rates, marriage rates, divorce rates, labor force participation, and my example, earnings. During the pandemic now, it was just reported in these last few days that, of course, we know that unemployment rate is increasing a lot in the country, but women are being the most affected by the pandemic in terms of losing their jobs. So women are losing much more of their jobs proportionally than men. And why is that? Even us being in a developed country, women still take all the charge, most of the charge of taking care of the kids. If schools are closed and they cannot take the kids to school, they won't be able to work. And some of their jobs don't allow them to work distance virtually. So they will be fired. And they are the ones having to deal with education of their children, taking classes in front of a computer. For you guys here who are already adults, it's already hard to stay in front of the computer, learning all these different subjects. For a child, it's even harder. So the woman has to give more attention, or the parent. And in our society, mothers are usually the ones giving all that, putting all the effort on that. So it's just to show that exactly because of our society is organized in this unfair way, that these tasks are not performed in similar ways between mothers and fathers, that then the mothers are going to be the ones more likely to lose their jobs during the pandemic. So when I'm going there, I'm explaining how the society is organized, why we have higher unemployment rates among women, why they are losing jobs in much higher rates than men. Demographers, they usually use the term sex even when they are discussing non-biological differences. Even when we're talking about differences in labor market outcomes, such as I said before, marriage, divorce, migration, usually, traditionally, we use the term sex. But it's just important to understand, although we are saying differentials in migration by sex, we are showing you the indicators, but then we have to understand why. Differentials in unemployment rates by sex, but behind the explanation to that are gender differences going on in our society. Okay? It's just important to know that. And as I'm going to show here in a couple of slides, fertility, mortality, and migration, the three demographic components, they vary by sex and by age. Okay? So fertility is first good to know these two different terms, fertility and fecundity. Fertility is the actual production of children. So how many children are being born in a specific country in a specific time. Usually, we have more males being born than females. So pretty much saying that fertility varies by sex. We usually have more boys being born. In the normal sex ratio at birth, usually you have 105 boys on average for every 100 girls being born. If there is not a preference for boys, because as we saw already in the previous lecture, for example, in China, where families there have a preference for boys, then they perform abortion when they realize that they are pregnant of girls. Even when they don't have a preference, the normal sex ratio at birth is usually 105 births of boys per 100 girls. And there are different theories or hypotheses trying to explain that. Why does it happen? One group of scientists, they mentioned that boys, they are weaker than girls. They're more likely to die before reaching 1 year of age. And that group of hypotheses of studies, they're called they bring up the hypothesis called the fragile male hypothesis. Boys are born weaker than girls, and they need more resources from families to grow and then being able to survive at older ages. When you have societies that give preference for boys and they have limited resources, like I said in the previous class, by giving more resources to boys, in the long term is going to affect the health of girls. But for some reason, and that's an open debate, maybe exactly because naturally boys are weaker than girls, boys on nature kind of adapted to that and produce more boys than girls, right? Because they will have higher chance of dying if there is not a cultural preference for boys than girls. If they are treated equally, boys will die more. And then by having more boys later in life, they will be equally divided, which goes back to John Grant analysis of data back with historical data from London. Another term is fecundity, which is pretty much the ability to produce children. At what age are we able to produce children? Demographers use this pattern of women between the ages of 15 to 49 being the ages in which they have children. Of course, we know people having children before they reach 15 years of age or at older ages than 49. But usually when we are calculating fertility rates, we are getting information of children from women between 15 and 49 years of age. And that's just because that's a standard and the data has been collected that for decades, for centuries. So, and actually, although we have teenage pregnancy, and that's important to calculate, for example, number of children for women between 10 and 14 years of age, that's important. That data is important for many studies. But if I just want to understand the general trends of fertility, the highest rates happen between 15 and 49. My image froze there again. It's just funny whenever I watch these lecture videos of myself, then I realize how much I move my hands, right? It's just like go everywhere. For males, this interval, the age interval is wider. It goes between 15 and 79. And just for those who speak Latin language, such as Spanish and Portuguese, these terms here are exactly the opposite. So fertility in Spanish is fecundidad. Fecundity is fertilidad. exactly the opposite. So you might have some confusion there if you're talking to someone with English as a second language, right? But those are the two terms that show, and previous studies have been showing that fertility varies by sex, or like we have more boys being born than girls. And also we have specific ages in which we are more likely to have children, okay? So fertility varies by sex and age. In terms of age, this is one example, just one example of age-specific fertility rates in the US. The black curve here is data from 2015 to 2020. And then the gray curve are projections to the years 2095 to 2100. And what we see, we are just focusing here on the groups between 15 and 49. So we get exactly those two ages that I mentioned before, 15 to 49 for women. And usually we divide those groups in 5-year intervals. So 15 to 19, 20 to 24, until 45 to 49. So usually we have these fertility rates, or these age-specific fertility rates, for these 7 groups of 5-year age intervals, right? So that's the standard. You could say, yeah, but people, again, below the age of 15 are having children, but those rates would be even lower than these ones here. And women already in 40 to 44 and 45 to 49 have much lower chances of having children. And you see that the highest rates, going to the data from 2015 and 2020, they are in the groups of 25 to 29 and 30 to 34, right? And that's the usually shape, this inverse U shape of fertility rates by age. And in the US, the projections are showing that we will experience a postponement in fertility. And postponement in fertility generates a series of studies across the world, because that has been happening in a series of different countries. How do I see this in this graph? You see, for example, here, for younger women, they are having less children. We expect them to have less children in future decades than in current decades. And older women between 25, 29, and 30, 34 are the ones who are going to have the highest rates, even higher rates than what we have in current years. And it's exactly because now, with the society, still a lot of differentials I just talked here about now, the pandemic affecting much more unemployment among women than men. But the society is getting a little more equal, giving more opportunities for women as well. So women also start going higher numbers to the school, to have a college degree, to have a graduate degree. So they first go to school, and then they organize their lives, and then they get a job, and then they finally decide to form a family. By doing that, they postpone the age in which they have children. But that varies a lot even within the US. We know that marriage rates and also ages in which women have children is lower, for example, in Texas than in New York, for example, right? But overall, women are delaying having children, which is related to them having better education, and then getting a job before forming a family. Any questions? Cool. And mortality also varies by sex and age. In here, focusing on variations by sex. Females have lower death rates than males at every age of life. This differential has been observed through the centuries and may be attributed to both behavioral and genetic causes. In terms of behavior, males are more prone than females to engage in health or life risk-taking behaviors, such as cigarette smoking. And series of like homicides, all these rates of deaths related to that is higher among men than among women. And in terms of genetic causes, estrogen, which is the woman's primary hormone, protects the heart and blood vessels. And testosterone among men acts in the opposite way, tends to promote higher blood pressure, suppress the effectiveness of immune system, and increase thrombosis. And as I mentioned before too, even when children are born, boys are weaker on average than girls. If you compare across and compare people, families with similar background, and exactly because of some genetic formation of boys, they tend to be weaker than girls and having higher mortality rates. But these differences are not only due to genetic causes, but also to cultural behavioral factors, okay? And mortality varies by age. Death rates are high in the first year of life and then drop to very low levels. So when babies are born, they have really high risk of dying. Until they reach 1 year of age, after that, their chances of dying decline a lot, right? In modern populations, the death rates do not reach the high levels of the first year of life for another 50, 60 years. So mortality is high before kids complete 1 year of age, and then it starts to drop and then increase again. But it's going to reach those really high levels of infant mortality just 50, 60 years later. And it's going to be clear to see that in the next graph. And cause-specific mortality is often age-related. And we're going to see throughout this course here some examples of mortality by cause, showing that young people are more likely to die because of car accidents, because of these kind of issues, external factors, than older people. Older people are more likely to die because of heart conditions, because of chronic diseases, right? So mortality varies by age, in the sense also that the cause of death also varies by age. Young people, they tend to die more for these external factors, and older people more related to chronic conditions and heart conditions and cardiovascular diseases. And just to explain this graph here explains exactly that. So what you have for mortality rates, you remember the previous graph that I showed you age-specific fertility rates. Now I'm showing age-specific mortality rates. In age-specific mortality rates, we show it to all the ages, from 0 until the last one. But instead of having a 5-year age group at the beginning from 0 to 4, usually have from 0 to 1 or less than 1, and then 1 to 4. Why do we break this group in two? The first group has 1 year of age, less than 1, and the second one goes from 1 to 4. Because the chances of dying are much higher among these newborn babies here before they reach the age 1 than when they complete age 1. Once babies complete age 1, mortality declines a lot. And that's clear for Nigeria, for Guatemala, and for Japan, based on data from 2011. And you're going to see that even for more recent data for other countries as well. And then this mortality rates decline. They kind of get stable for a little while, and then they start to increase again. People start to increase the chances of dying. But as I said in the previous slide, death rates do not reach the level of the first year of life for another 50, 60 years. See this high level of mortality here, we're going to reach again, based on this data from Nigeria, just when they are around 70 years of age. In Guatemala, when they are around 65 years of age. In Japan, when they are around 45, 50 years of age. Okay? So just to show, we also have this kind of pattern, a different pattern that we saw from fertility, but also mortality rates really clear associated with age and similar patterns for different countries. The level can be different, and sometimes also the shape of the curve can be more concentrated. We see here Japan more concentrated and Nigeria more spread with high levels of mortality. And in terms of the age group, the last age group that we have here for this graph are people with at least 100 years of age. Not all countries for all the years you can collect such refined information. So you might see some graphs that just go up to 80 plus or 85 plus. 80 plus and 85 plus are really also standards to calculate mortality rates, right? And we're going to see that also more in the chapter about mortality. Migration, the third demographic component, also varies by sex and age, especially in developing countries. Sex is related to the distance of migration. In developing countries, men and women have really different opportunities in life. So those people that are migrating to long distances, proportionally, you have more men migrating long distances than women. In short distances, if you're just talking about migration, even between rural areas or from a rural area to a small city around it, or between two big cities, whenever you're talking about short-term, short distance migration, proportionally, you have more women migrating than men. But in countries such as the US, Western Europe, Canada, when you have increases in gender equity, migration of females and males tend to be similar in terms of distance, okay? Migration is age selective. That's something that I mentioned to you guys earlier today. The largest numbers of migrants are found among young adults, so those between 20 to 29 years of age. That's where we see high levels of migration. But that varies a lot from country to country, right? But overall, the pattern of migration rates by age is this one here. So it's a little bit more complicated because you have a decline of migration rates from young ages to more teenage years, and then it increases again among labor ages, people migrating to try to find a job or going to school and so on. And then people start to get more stable, they marry, they have children, they get a job, more stable job, they start to have less chances of migrating. And as they get older, the chances of migrating also decline. Maybe later in life, these migration rates can increase a little bit of people moving to institutions to take care of the older population. This graph here is really interesting. If you compare, usually these people here that they start to have jobs and then get married and start to have children are less likely to be less likely to migrate as they get a little older. And the rates of these children here reflect the rates of their parents. So these are the parents moving with their children. In this case here, we are seeing that their parents are taking the children with them, migrating within the US. This is inter-county migration, people moving between counties, right? Some countries that you have people moving, for example, from rural areas to urban areas, but just the father goes, the mother and children stay behind, then these rates here tend to be much lower. They don't mirror the rates of parents, right? So that you're going to see a lot of variation between countries when you're talking about internal migration. What about the age range here? Like I said before, the upper range, you usually go up to 80 plus or 85 plus. It doesn't go much more than that because migration is a rare event. So it's hard to find people in those later ages that migrated. So you group them 80 plus or 85 plus. And why we start on 1, not on 0? The question that is asked here in the US and also in several surveys, and this data here is from the American Community Survey. That's the American Community Survey from 2012. American Community Survey is a survey that's implemented in the US every year nationally since 2005. That survey, with a lot of refined information, was also implemented to a sample of the American population in census years up to 2000. After 2000, the census just asked a really short questionnaire to everybody. So 2010 and 2020, the one that you just answered last year. The long form that in previous censuses were implemented to a sample of the population, now they are also implemented to a sample of the population, but every year. 2005 and the data for 2019 is already available. And in the American Community Survey, the question is, for all the people here living in this household, where were they living? Which county did they reside exactly 1 year ago? The census date is April 1st. So in 2012 was April 1st, 2012. So the question is, for everybody here in this household, tell me where that person was living exactly on April 1st, 2011. And if I have a baby that's younger than 1 year of age, exactly 1 year ago, that baby was not alive. So that's why we don't have information for children below the age 1. There is another question in migration that's not asked in the US, but is asked in other countries. The question is, where did you live before you live here? So that question can be asked to someone who is below 1 year of age, because a baby could have been born in LA and moved to Texas when the baby was 3 months old. And if that baby is asked in Texas, oh, where did you live before? In California, in LA. That's exactly the case of my twin babies, now toddlers, right? 3 years and a half. But in that case, if in that year of 2018, it was asked that information to them about where they were in 2017, 1 year ago, they would not be counted. But if they were asked, or their parents were asked, where did you live exactly? Where did you live before? That kind of question would capture them, okay? So it depends on how the question is asked. The way that is asked here in the US exactly 1 year ago is the one that has been more widely used across the countries. And it's easier too, because it gives exactly date on which I want to know about where you lived. And the other question is usually asked in connections with a second question, because it asks, where did you live before? And how many years do you live currently here? In our case, in College Station. So you have to answer 2 questions. Only after you answer these 2 questions, you actually know how likely you were to move to College Station and from College Station, right? So just to show that even the years that we have here, the age range, they vary in the graphs for fertility, mortality, and migration because of the specificities of each one of these demographic components. And the pattern of the curves are completely different, right? What we usually have in migration, the data, when it's like data that's not really reliable, we have a lot of variation in these rates here. So we have to implement some mathematical models to kind of try to smooth the curve. These mathematical models started being implemented first to fertility and mortality. Now we already have those for migration as well. But the study of migration in terms of modeling migration is much newer than fertility and mortality, okay? And some general theoretical discussions that we have, why age and sex structure is important for us to understand the structure of the population by age and sex, because they help us understand the demographic history of population. If we get data from previous years, we can compare to more recent years, and we can kind of try to see what were the effects of changes in fertility, mortality, and migration on the structure of the population by age and sex. As we saw before, persons of the same age constitute a group or cohort who were born during the same period. We talked about that in the previous graph, in the previous lecture. Therefore, they have been exposed to similar historical facts and conditions. These experiences also differ according to sex. So experiences of people in societies, which kind of jobs they have available, which kind of opportunities they have available, which kind of opportunities for education, or if they live in a time where you have economic depression, or you have wars, all that will affect their lives. And that's related to age. And if I live in a society in which women have much lower opportunities for good jobs and good education than men, that will affect a lot their outcomes compared to women in newer generations, right? Income, home ownership, occupation, or group membership are likely to vary by age and sex. So age and sex structure help us understand several other indicators, several other factors in our society, okay? And this concept of organization is also important to understand. Age and sex structure of human populations sets important limits with respect to sustenance organization. The demographic structure of age and sex contains the possibilities and sets the limits of organized group life. So that's a sentence from this demographer. You might say that the proportion of children that we have in a society, the proportion of people in labor ages, the proportion of older people, the proportion of women and men, they will be the basis of how we are organized as a society, as a group. The degree to which a population's age and sex structure limits the kinds of sustenance activities is an important analytical issue. So how age and sex structure affects society, affecting even the resources that we have, it's important to understand, even historically speaking, and there is a lot of room to be still explored and to be still understood over time and across societies, okay? And some examples of researchers, demographers, that try to understand general patterns of age structure, sex structure in countries are those ones here. Ansley Cole, he developed marriage patterns by age, kind of showing that people are not likely to get married equally across all age groups. Usually it's in their 20s and their 30s. And he tried to show that and model that in a way that we could compare societies. Louise Henry, description of fertility patterns by age in the absence of voluntary fertility control. He was pretty much trying to say, how would be the fertility rates, the level of fertility by age, if those societies didn't have access to any contraceptive method? So he would do that theoretical work and then compare to the actual level of fertility that's lower than that, because women, they do have access to contraceptive methods. And this differential would say, let's say, in which stage those societies are in terms of differentials in fertility by age. I just mentioned to you some mathematical models that try to smooth the migration rates by age. Andre Rogers, he retired, but he was a professor at University of Colorado Boulder, and he created this mathematical model exactly trying to measure the level and the steep of each portion or of each stage of the migration rate. So for example, here, if we go back to that graph of migration rate by age, his mathematical model generates one indicator to indicate what's the level of child migration, how fast is declining, how fast this one is increasing, another indicator to indicate the level of this labor migration, how fast it declines, and then also information about older age groups. So this is more like a mathematical model. Try to simplify these age specific migration rates in simple indicators instead of having to show all these rates in the graph. And then the stable population theory, we're going to talk more about it in the mortality chapter when I'm going to talk about how to estimate life expectancy at birth. when we estimate life expectancy at birth, we use a technique or a table, a set of calculations called life table. And with the life table, we can have really good information to project the population by age and sex for future generations. And all these projections are based on this stable population theory. It's really simple to calculate how the society would be in the future if the levels of fertility and mortality doesn't vary as much from the current levels. So let's say, for example, in these last decades, the fertility in the US declined a lot, but in more recent years, it has been kind of stable around 1.76 children per woman. And mortality rates also decline a lot by age in these last centuries and last decades in the US, but now have really low levels. Of course, the pandemic is creating some variation there, but overall the levels of fertility and mortality decline so much, they are kind of like stable. We can use the stable population theory to kind of say, if this level of fertility and mortality don't vary too much, what's going to be the age and sex structure of the population in the next decades? If it doesn't vary as much for these next decades, we can use this stable population theory to do these projections. So a lot of projections use this approach. But then you can say, oh, but the age-sex structure can also be affected by migration, not just by fertility and mortality. If you have a lot of people entering one country or live in one country, immigrants are usually between 20 and 29 years of age, that will affect age structure. So the stable population theory takes into account only fertility and mortality, does not take into account migration. Whenever in demography we are doing an analysis that we are trying to understand changes in the composition of the society, taking into account fertility and mortality, but not taking into account migration, we are doing an analysis with this assumption of a closed population. So whenever demographers talk, oh, all this study here is considering a closed population. Closed population is because I'm not considering immigration or emigration. I'm just considering variation in fertility and mortality. And that's the case of the stable population theory. Exactly what I just said. The stable population theory considers a closed population, a population in which migration does not happen. Just takes into account variations in fertility and mortality. And the idea is what I said now with my example about the US. If a population experiences constant age-specific fertility and mortality rates. So fertility and mortality rates in the US declined a lot in these last decades, but now they're kind of stable. I mean, I show you the graph for age-specific fertility rates in the US for 2015, and then the projection to 2095. They kind of vary. I showed you that they are varying, but kind of stable as well. The overall pattern is not changing so much. So if you have societies like that, in which the fertility and mortality rates by age groups are constant over time, it will tend to develop a constant age distribution and grows at a constant rate. And it doesn't matter how the original age distribution was. If you reach this level of fertility and mortality by age, and it doesn't vary as much, those rates by age groups, mortality and fertility rates, you have an idea of how your society is going to be in the next decades. And demographers sometimes indicate that stable populations forget their past, in the sense that it doesn't matter how the age distribution was. If you have this distribution, this level of fertility and mortality in the society right now, by age group, not varying too much, stays like that for the next decades, I already know how the age-sex distribution is going to be for that population. The age distribution of a stable population depends on the underlying age-specific mortality rate. The mortality rate is the most important, even more than the fertility rate for this analysis here. Because fertility is usually around 2 children per woman. And also, not only the age-specific mortality rate, but the overall rate of growth. So it's more about the mortality rates by age group, but also the overall number of children being born in that society. Because if you have the overall number of children being born in that society, we can also estimate the overall number of people dying, and then the rate of growth, right? So for this analysis, we don't need specifically the fertility rates by age group. We just need the overall number of people being born, mortality by age group, and then we can also estimate the rate of growth with these two sets of information, right? And we're going to talk more about this in the mortality chapter. And when we have a society in which the number of people being born and the number of people dying is equal within a specific year, we have a stationary population. So the stationary population is one kind of a stable population. So I said the mortality rates by age group are stable over time. The fertility rates by age groups are stable over time. But overall, one specific country in a specific year can still have more people being born than dying. If more people are being born than dying in a specific year, what happens to the population size? It increases. It has a positive growth rate. If we have less people being born and more people dying, what happens to the population size? Decreases. So we have a negative growth rate. If in that same society, the overall number of people being born and dying is similar, then you don't have population growth and you don't have population decline. In that specific case, we have a stationary population. It's one of the three kinds of a stable population. The stable population can be one that you have more births, population increases. The second example, more deaths, population decreases. Similar numbers of birth and death, population stays the same level. And that's what a stationary population is. This results in no change in the size of the population and the stationary population is one kind of a stable population. In all the stable population theory, we are doing the analysis of changes in fertility and mortality with the closed population assumption is still under place. So we are not considering the influence of migration. If I have a population that receives a lot of immigrants, I will have to refine my projections. That's the case of the US. I can start with the stable population theory, analyzing the trends of migration, of fertility and mortality. And after I have a first set of estimates, then I consider immigration and immigration levels, right? But this is just to show you how the society having specific composition in terms of age and sex might actually make us understand how that society was in the past and how we expect the population to be in the future, doing projections of this population. Okay? Now, a less theoretical topic, really simple thing, something that you guys learned in high school. Population pyramid. Population pyramid is a graph, pretty much a graph showing the age and sex structure of a population in a specific year. And it also is called age-sex pyramid. And because in more recent societies, the population distributions do not have necessarily the shape of a pyramid, some of them are more rectangular, we simply call this graph an age-sex structure. It's a graph to show the age and sex structure of a specific population in a specific year. The population pyramid is pretty much two bar graphs together. You have the bar graph, the horizontal bars, and then you have on one side man, the other side woman. That's the horizontal. And in the vertical axis, you have the age groups, right? So you have the sex structure, men and women in each side, and then the age groups in the vertical axis. The population pyramid is nothing more than two ordinary histograms that represent male and female populations, and usually demographers show them in 5-year age groups. For societies that have more refined information, they show the pyramid with data for every single age, right? For 1 year, for every single age, for 1 year age categories. A main characteristics of age transitions is a change from a very young to an older population. So here, you can go to this website, populationpyramid.net. I got this data from there. And the link, it's also at the bottom of my website, but that's it, populationpyramid.net. This is the age-sex structure of the world back in 1950. Population had like around a little more than 2.5 billion people. On the right side here, we have women. The left side, you have men. The horizontal axis here is in percentage terms, but we could also have that horizontal axis in absolute terms, like in millions, instead of in percentage. And you have in the vertical axis the age groups from 0 to 4, 5 to 9, until 100 plus. And in this case here, we have 5-year age groups. That's usually the standard that we're going to see. So I just downloaded this data from there, 1950. And what did we say in this previous sentence here? The main characteristics of age transitions is a change from very young to older populations. So you see in 1950, how you had a really high proportion of children between 0 to 4, 5 to 9, 10 to 14, 15 to 19, compared to older groups. Up to here, until 15 to 19, you had this one here, the fourth one, these percentages are higher than in older groups. So you have a young population. You will start to understand the age structure of this country. Overall, you have more boys surviving up to the age 4 here compared to women. But then when you reach older ages, the percentage of women increase and it's higher than men. It passes here around 45 to 49, 2.6 against 2.5, 2.2, 2.1, and so on, right? Because women live longer, and then in older age groups, you have more women than men. That's one graph. For 2000, then you start to see that the base of that graph is not so wide anymore compared to the previous one. The group of 0 to 4 declines a lot in size. It starts to have, people start to have fewer children, and then the percentage of those in younger ages decline. 2020, people are just getting older and jumping up, and these people here, the chances of dying decline, so they will survive to the next age groups, and this one's the same thing, you survive to the next one, so the pyramid starts to have a little bit of a more rectangular shape. That's 2020, and then the projected population for 2050. And then you start to see these people here surviving to older ages, surviving there, but still, some countries with still high mortality, not as many people surviving to really older ages, and sometime we will die. But overall, it changes the shape of the age-sex structure of the world in this case. And here the population is expected to be around 9.7 billion people by 2050. And by 2100, expected to be around 10.8. And then you see a really rectangular, and across the age groups, you see much more similarity because these people are surviving to the next age group until they start to die in the decline. But as developing countries also improve mortality in the sense that less people die, people live longer, these differentials here will start to get even smaller and more people survive into older ages. This is one example of an age-sex structure with really refined data. And here you have data for single years, for 1 year of age instead of 5-year age groups. And this is for France, data for 2006, again, males and females. The vertical axis goes to 105. The horizontal axis, like I said before, could be expressed in percentage. Here is expressed in thousands. So here we have 100,000 people. Here we have around 370, 80,000 people. And then when you start to look at the pyramid, you start to understand why in some cases you have these dips here. Why here you have fewer people compared to those around, even older people or younger people. Number one, that's the birth deficit due to World War I. A lot of people die, you have these depleted cohorts there in absolute numbers. Number two, depleted cohorts reach reproductive age. What does it mean? These guys here are the children of these guys here. Right, the number two here are children of the ones here on number one. So since you have fewer people because they died because of World War I, they will have overall fewer children. 3, birth deficit due to World War II. Then we reach World War II. And then you have all this huge decline here compared to younger generations. And the interesting thing about this graph is that the vertical axis, you have the age, but they also put the year. Because by putting the year of birth, this is all data based on 2006, but this is the year of birth of these people here. And it's just by putting the year of birth, you can understand these historical events. Number 4 is the baby boom right after World War II. A lot of people died, and then you have some economic development, economic growth. People see a better life, better opportunities, start to have a lot of children. 4 and 4 here. And then after some years, you will start to have a decline in fertility again. You have the end of the baby boom, and then fewer people are born. And these people that were born here, they have these children here. So baby boom finishes, but then these guys reach reproductive ages, and the number of babies start to increase again. So that should show how one generation that increased fertility in the baby boom, that's going to have effects in older generations as well. So, but in one graph, you can try to, you can understand a little bit of the history of that country. And here I just collected data for 2010 and 2050 for India. And that's the website that I got this data from. This is just to show, as we saw in the age-sex structure for the world, India also had higher proportions of the population, higher absolute numbers of the population in younger ages. And even in this developing country, you start to see decline in fertility. So you expect by 2050 to have fewer children younger ages. And the horizontal axis here is in millions. So here we have around 55 million girls between 0 and 4 years of age, okay? But also decline in fertility, improvements in mortality, more people start to live to older ages. The same years, 2010 and 2050, to China. And China had even stronger fertility declines than in India. China, because of economic development, but also because of the one-child policy between 1979 and 2015. You have fewer children here than what we saw before in India, and this scale here is the same, from 0 to 65. And as these people get older and fertility is still in lower levels, really low numbers of children, and a lot of people in labor ages. What China is going to experience already started to experience, is going to experience in these next decades, is that these people here who are still in labor ages between 15 and 65, 10 and 64, they will start to get older. And the conditions, health conditions are getting better, getting older. You're going to have, in absolute terms, more older people than people in labor ages. So that's going to create a lot of pressure on the society. That's why now they relax the one-child policy, trying to make people have more children. And there is even like people going to other countries around China to get married and form a family. You have more men than women, exactly because of preference for men, right? The numbers here are a little higher than what we see for women. And this is for the European Union. Fertility declined even before than these developing countries. So you have really lower numbers. And here the horizontal axis is not the same. It's going just to 20 million. And number of children already much lower. And as fertility continues to be low, people living longer, you are seeing pretty much here population aging in the European Union as well. Just higher proportion of people in older ages. And this data here is from 2012. So in the UK was still in the European Union in those graphs, right? So the UK is included there. This is the US. The fertility is not so low as it is in the European Union, but it's kind of like stable around 1.7, 1.8. So it doesn't decline as much, but because we have a lot of immigrants too, and immigrants tend to have a little higher fertility than US-born people, but also you have been experiencing an increase in the number of people in older ages. So really simple graphs we can tell a lot of story about those countries. This is Llano County, west of Austin, north of Fredericksburg. And just to show how we have high percentage of the population above 50 years of age. And here you have Brazos County, high proportion of the population between 20 to 24, exactly, college students in town, right? In the course website, I put this, an Excel file. I will show it next class, examples of age, sex structure, and other indicators. So it's pretty much a file that you uncompress it, and you're gonna have a lot of different graphs in Excel. The bar chart here, age, sex structure, Brazil, I just show how you get data from each specific year by sex, male, female, by age group, and then you can generate these graphs. And you can do that by yourself. You would just have to get for the same year by age for men and for women, and then you can have the graph with age, sex structure. Okay, so the quiz 2 is now available on the on Canvas. It's going to be available until tomorrow at noon. Same thing. 2 questions, and it's going to be still about chapter 1, because I knew that I was not going to finish the chapter about age, sex structure. So the 2 questions for this quiz is still about the first chapter. Okay. If you have any questions, if you want to have office hours, just email me and we can schedule. And I can also answer questions by email. Thank you very much. Have a great weekend, and I see you guys on Tuesday.